I think this kind of the size of the crowd is an indication that you've been hearing a lot about heat pumps and wondering if it might be right for you. So hopefully you'll get your answers today. So Mike Simons, we are so lucky to have him. He actually did the training for energy advocates, which is what my position is, for people in my position all over the state. And it was really interesting. As in my head, I was thinking, wow, that all makes so much more sense than I've ever heard before. And in the comment section of the webinar we were having, so many other people were saying that same thing. So we thought he'd be the perfect person to bring here today. So Mike has been involved in building performance for over 10 years, from running over 1,000 mass save energy audits to training over 150 energy auditors. He's learned how homes work and what can be done to fix them. After that experience, he was fortunate to be part of the launch team of 2 energy efficiency companies, the first being a home performance contractor that has since grown to be the 2nd largest in Massachusetts. His current employer, Abode Energy Management, has him doing what he does best, developing and providing comprehensive training related to energy efficiency. He says whether as a BPI proctor mentor or teaching emerging professionals building science or making heat pump design understandable, he tries to put the fun in the fundamentals of energy. His certifications include Building Analyst, Envelope Professional, Healthy Homes Evaluator, and HERS Rater. Please join me in welcoming Mike to speak to us today. Thank you.
So, yeah, just to get started, we're going to spend about an hour talking about heat pumps. Do know that as we are thinking about heat pumps, it's a large product category. So outside we saw a ductless mini split, and that's what they're dealers for. They also do central heat pump systems, and even understanding central heat pump systems, there's different subcategories in there with like a central mini split or say a centrally ducted one, and the performance is going to really vary depending on what gets installed and selected and what your goals are for the project. We'll also talk about some of the emerging technologies as well with like air-to-water heat pumps, heat pump hot water heaters, ground source heat pumps. So hopefully by the end of today you won't feel too overwhelmed, and I really think that part of the goal of today's presentation is just understanding what heat pumps mean in existing homes and structures and how they can work or can't work, or if they can't work in your home, what can they do? Just understanding capacity balance point, economic balance point, and just figuring out like what makes the most sense for your own goals. Just a little bit about the company that I work for, Abode Energy Management. So in the Mass Save program, there's kind of this like standard Mass Save path where you call a 1-800 number, and then they send out an energy auditor, and then they sub out the work to an independent installation contractor. That's one path that Mass Save has to help people get their home more energy efficient. There's another path called the Home Performance Contractor path, where it's independent companies that are participating in the Mass Save program, and those companies do their own intake, they do their own energy audits, and then they have their own weatherization trucks. And the company that I work for, we oversee the work quality of those companies. So part of our DNA is 100% knowing how homes work in Massachusetts and what we need to do to fix them. And then the other half of our DNA is running a handful of heat pump programs throughout the state, through the entire state of Connecticut, as well as working with the Mass Clean Energy Center and running their decarbonization program. So that's decarbonizing existing buildings so they're more or less net zero, or that's the goal at least. You already learned a little bit about me, so I'll skip over that slide and we'll just get started with talking about heat pumps. So with a heat pump, it's a heating system, but unlike every other heating system that's been used throughout human history, there's nothing being set on fire on the site. So it's an electrical appliance, and all that electric appliance does is it takes energy in the winter time from the outside air. It takes that energy, it transfers it into a refrigerant, and then it dumps that refrigerant throughout the home. And it can do it in a variety of different means. Typically it's through forced hot air. And if you pass by a ductless mini split on your way coming in today, that's a very common way that that energy is then distributed throughout the air. Fuel prices fluctuate, but say in the winter of 2022 into 2023, pretty much most heat pump systems are going to be more cost effective than burning home heating oil or burning propane. Natural gas is relatively cheap in Massachusetts historically, and electricity was relatively expensive. So the combination of gas, thinking about gas and economics in heat pumps, will look a little bit closer. It's a little bit harder of a sell, but kind of where we're located in the state, for better or for worse, we really don't have to be worried too much about thinking about the economics of natural gas versus whole home heat pumps. Heat pumps are cooling systems as well. So instead of stealing heat from the outside and dumping that energy into the home, it could steal heat as well as moisture from inside the home and dump that outside the same way a central air conditioner does. And then typically when you are thinking about a heat pump in cooling mode, it's typically anywhere between 2 to 3 times cheaper to run than a window air conditioner. And I'll be adding on layers and layers of nuances, but sometimes when someone spends $5,000 or $15,000 or $40,000 on brand new mechanical systems in the home, they may end up running their heat pumps a little bit more than they'd be running their window AC, so sometimes the savings is not actually realized. And just lastly, with the heat pump system, it's an HVAC system that was developed in the last year or so. So typically, like, it's more quiet, it's more comfortable. It can have the ability to provide better indoor air quality than your traditional HVAC system. So I don't spend too much time getting nerdy about the science of how a heat pump works. But let's just think about this real quick. So we have 3 components. We have the outdoor piece of equipment, we have the indoor piece of equipment, and then we have a line set carrying refrigerant to both of them. Some like thermodynamic concepts is hot goes to cold, and as you increase temperature, that's going to equal an increase in pressure. So let's just think of what's happening over here. Say it's 0 degrees outside. We're going to need this to be colder than 0 degrees. So what they do is they drop the pressure of the refrigerant when it's going inside, and now this refrigerant inside of here is going to be like negative 15 degrees. Hot goes to cold, and eventually this refrigerant is going to become 0 degrees as well. And then they just pressurize the heck out of it, and by the time it reaches the home, this pressurized refrigerant is like 100 degrees. And air from inside of the home is typically passing over these coils, and then your 69-degree air passing over these 100-degree coils blowing out 80-degree air will make your home 70 degrees or 72 degrees or whatever you want to set it at. Finally, they drop the pressure, and this refrigerant suddenly becomes negative 15 again, and the process repeats and repeats and repeats. So sometimes when I'm not talking to a technical audience, when someone asks, how does a heat pump system work? I just say, oh, it works great, or it works better than you would ever expect. So I don't need to talk about like the scientific thermodynamic explanation. And in the summertime, it's just the complete reverse of it. And this may sound like a cop-out, but how does a refrigerator work in the summertime? The same way as your refrigerator does. It's just taking heat from inside the box, your refrigerator, and it dumps it outside the box into your kitchen. It takes the heat from inside of your home, which is the box, and it dumps it outside of the home. And it just happens again and again and again, and then in an ideal world, your home's going to be nice and cool and dry and comfortable in the summertime. So how does a heat pump become so much more efficient? Like, why are we excited about it? And it's this, which is kind of like the magical equation of it. And I know that there's some people who may have a math background and say that you can't have something that's more than 100% efficient, but let me just go through the logic over here. So say you buy home heating oil, you buy a gallon of it, you put it into a contraption that looks like this, either a furnace or a boiler. a percentage of that energy ends up going up the chimney. It's lost, it's not brought into the home. Then you go and you say, take that energy and then you convert it into steam or forced hot water and pipe it through the home through uninsulated pipes or somewhat uninsulated steam pipes that because of an asbestos remediation project. And by the end of the day, this 1 gallon of home heating oil, you're only getting a percentage of that energy brought into the home, converted into heat. Say instead you used electric resistance, like a space heater, a toaster oven, a blow dryer. You're putting in 1 unit of electricity, and 100% of that electricity got converted into heat to switch the bread into toast, or it also, the rest of that energy just made its way into the kitchen. But you put in 1 unit of electricity, you get 1 unit of heat, because all of the inefficiency over here happened downstream at the power plant, at the transformers. With a heat pump, because you're using electricity to move heat versus electricity to generate heat, you put in 1 unit of electricity. In our region, you end up with about 2.8 units of heat with a well-designed air source heat pump system. And that becomes what makes it so much more efficient than what we're used to. So some people, when they're thinking about a heat pump, they say that it's 250% efficient, 300% efficient. And if we were in, say, Bermuda, it would be like 500% efficient just because it's warmer outside and it's easier for the appliance to extract energy from the outside air. So when we're thinking about a heat pump's efficiency, it's in terms of coefficient of performance. So now I think this is when it's going to start becoming like more useful for you as you are imagining heat pump systems. So we have 3 different types of homes over here. And do know that even though this one looks older and leakier, you could easily have a Cape Cod style home that is also going to need 100,000 BTUs per hour. But let's just explain what some of these numbers mean. So if you go into your basement and you look at your heating system, or say you bought a wood stove or a pellet stove, the metric that they would have used to say how much heat can this system provide is in British thermal units. And just so you know, in Britain, they do not use British thermal units to identify how much energy a system has. But most homes, when you're putting in a heating system, it's going to need 100,000 BTUs per hour. And that number is to replace kind of the worst case scenario of how much energy flows out of the home over the course of an hour. So I think your design temperature in Shelburne is around 2 degrees Fahrenheit. So when it's 2 degrees Fahrenheit, if you want to maintain 70 degrees in this home, you need to add 100,000 BTUs per hour. And say with this Cape Cod style home, 50,000 BTUs per hour. In this home that went through a deep energy retrofit, 24,000 BTUs per hour. So as say homes get more energy efficient, it's going to lower the load of the needed heating system. Now I'm going to look down over here and I'm going to see 2 heat pump systems. This heat pump system on the left-hand side, it provides 30,000 BTUs per hour when it's 47 degrees outside. And this heat pump system over here also provides 30,000 BTUs per hour. But when we look closer at, say, the performance of the equipment, when it's 5 degrees outside, this heat pump only puts out 12,000 BTUs per hour. And when you hear heat pumps don't work, it's typically because someone opted for this type of equipment. And we refer to that as a system that has a capacity drop. The one on the right-hand side, it looks the same. It performs the same at moderate temperatures, but this would be called like a hyperheat system. Or we saw Samsung equipment outside. They refer to theirs as max heat. Fujitsu calls it XLHT. Like a lot of different brands have a type of equipment that doesn't lose any of its heating capacity until sub-zero temperatures. So over here, 5 degrees outside, this heat pump has 30,000 BTUs per hour. I could take this leaky farmhouse, and and I could put in 4 of those heat pump systems, and I could be heating the leaky farmhouse with that equipment, and I'll be just as comfortable as what you're used to. Cape Cod style home, 2 of those systems. High performance home, 1 of those systems. So there's nothing about heat pumps don't work or can't work or don't work as well. It just is a matter of first starting off with the heat load and matching the equipment to it. So I can speak confidently about this because that's what I did for my own home. So I live in central Massachusetts. I'm in Leominster. I totally concede that it's a little bit warmer over there, so maybe it's not as hard to design a heat pump system. But I have like a big 4-square colonial style home. And when I bought it about 3 years ago, there was single pane windows, no insulation in the walls, a complicated thermal envelope upstairs. And when I went and I modeled the home using what's called a heat load software or manual J software, it told me that I needed 108,000 BTUs per hour to heat my home. And the steam boiler that came with my home, it produced 129,000 BTUs per hour. So the heating system could provide more heating horsepower, more heating capacity than my home would ever need. So there was no problems outside of clanging radiators and high energy bills with the steam system. It could heat the home fine. There's things that I didn't like about the steam heating system as well. So what I did is I didn't design my heat pump system to heat my home as is. I made some simple and obvious energy efficiency improvements. So I packed my walls full of insulation. I got my attic figured out. I had Mass Save do as much air sealing, and I'm personally not done doing more additional targeted air sealing. And then I also upgraded my windows. And pretty much all of those measures are all things that Mass Save can help support. And after I did those measures, instead of needing over 100,000 BTUs per hour, now it's 48,000 BTUs per hour. And if I went and I selected, say, this type of heat pump system, and I went into the manufacturer's submittals, I would find out that this heat pump system can provide 54,000 BTUs per hour. So this system provides more heating capacity or heating horsepower than my home would ever need. There's a separate discussion that I'm happy to have in the back with regarding like resiliency and redundancy, as well as polar vortexes and snow apocalypses. But with this heating system, it provides, as designed, as much energy as my home would ever need. And I'm happy to say that I'm on year 2 without ever needing to turn on my steam boiler to be supplementing for additional heat. Some other key takeaways as well is, say if I did go and stick this heat pump system into a home as it was originally performing, my annual heating expenditures, and I will say that this was last year's rates, would have been $3,200 instead of $1,600. It also changed my install cost from probably around $50,000 down to a little under $25,000. And then the other thing too, it's like we do need to be electrifying everything, according to people who are making sure that we have a sustainable planet. And if I just put in 2 of those systems, then I would have been taking up an additional 30 or 40 amp breaker. And we need, I'd like to have a level 2 EV charger. I'd like to have a heat pump hot water heater or solar thermal system. So it would be taking up useful space on the main electrical panel, kind of sizing the HVAC equipment for the load as is. What I want to talk about before I go into the actual economics is, in Massachusetts, there are towns that heat pumps make tons of economic sense, and then there's towns where it's less so. So we, over here, you have an investor-owned utility, and I'm sure you've all seen in the news that electric rates have shot up, particularly around the supplier charge. With Shelburne, you have a community aggregation program, and what ended up happening, instead of your electric rates going up to 22 cents on the supply charge this winter, it ended up going up a little under 10 cents. And this is like one of the things, as well as putting on on-site solar PV, that can make the heat pump economics so favorable. So we're going to see a slide in just a little bit of what this actually means in terms of economics. And then the other thing that I'll just say is there's a lot of different calculators that you can use to be kind of plugging in some information and seeing the price of oil, propane, natural gas versus heat pumps, and MassSafe has one of those. But I will say that if you're a Shelburne resident and you're part of the community aggregation program, the numbers here are not going to be reflective of a much lower rate that your energy committee in your town work with the Department of Energy Resources to get those rates locked in. So it's a really good option. So this is the chart that's going to need a little bit of explaining, but let's just look at what it is. So these lines over here, the vertical ones that are in this gray color, these lines are the total count that we spend at each of the different temperatures. So over here on an average winter, we spend, say, around a little over 180 hours at 60 degrees. And then at 32 degrees, it's still like 180 hours. And then once it's below freezing, we start to see those trailing off. If I'm looking over here, I'll see some different colored lines, and the colored lines are related to the different fuel sources that we have and how much it would cost an average size home to heat for that 1 degree at the various different temperatures. And what we can clearly see is, whoa, electric resistance is a lot more than propane. Propane is more expensive than home heating oil. Home heating oil is more expensive than natural gas. And then the green line is air source heat pumps. And because your town, when you kind of look at the all-in cost per kilowatt hour, is around 27 cents, it becomes more favorable to natural gas, as long as the system's well designed, to right around 29 degrees. So what I would be thinking about if I had the option of heating with a heat pump or heating with natural gas, and I wanted the cheapest operating cost possible, I'd probably say, yeah, I'll run my heat pump anytime that it's above freezing, and anytime that it's below freezing, I should maybe switch over to natural gas to keep the cost as down as possible. But at the same time, I could just be like, you know, I'm winning with the heat pump over here, and I'm losing with the heat pump over here, but it just balances out. I'm going to ditch my natural gas system and just run my heat pump system. But if you have home heating oil, or if you have propane, we're even going all the way down to kind of these like, you know, well below freezing temperatures, it really is like heat pumps are just as economical to run when home heating oil costs $4.25 a gallon or propane is $3.75 a gallon. And then the other thing that I just really love about this chart over here too is there is geothermal on there as well, and we would see that geothermal, if you have a good site for it, would be the most economic to run throughout the temperature spectrum. So this is kind of a better understanding of how good you guys have it compared to other people in Massachusetts. So over here is your Shelburne rates, and this green line, as we said before, is the air source heat pump system. And say if you're just an Eversource Basic customer, the math just completely flips. So with Eversource Basic right now, it's like, yes, it's cheaper than propane, yes, it's cheaper than home heating oil, but just right at, once you're below freezing, it really does make economic sense to be switching over, because you can even really see kind of like, oh, the heat pump, when it's working really, really hard in these really cold temperatures, there is a much bigger economic disparity between the two. So you're somewhat of a unique community. There's a handful in the states that set up community aggregation programs, but it really does make it so much more of a no-brainer. So I'm always thinking about whole home heat pump systems, but even if you're just putting in a little bit or starting small, there's absolutely nothing wrong with sizing a heat pump system to be meeting with, like, to be covering the load of half of the house. So do know that if you start off small and just put in a ductless mini split to pick up, say, like your cooling load, Like that's what you size it to. That one system or those, say, 2 ductless units are likely going to be displacing probably between 70 to 80% of the total energy that's consumed. So it really could be a meaningful thing if you are just trying to be reducing your carbon footprint. All right. So we're now going to just talk about some of the different design options. So what we saw outside is a single zone mini split system. One outdoor unit talking to one indoor unit. At the same time, all of the major manufacturers, they also make multi-split units, where sometimes it's one outdoor unit talking to up to 4 indoor units. And these indoor units could be ductless, and we'll be talking more about ducted heat pumps in a little bit. And then they also have these big multi-zone systems, and with these big multi-zone systems, instead of connecting directly to the indoor units, they connect to these manifolds or branch boxes that could be down in your basement or up in your attic. And then maybe, like architecture is important, and sometimes like having like 3 sets of line sets or 8 sets of line sets going from the house to the outdoor unit is less than ideal. And sometimes with these big branch box systems that have the manifold, it could be a much cleaner install on the outside of the house. So do know that those are a reality. For different types of ductless units outside, they have a wall mount. They're typically the most, they're typically what gets installed the most for a few reasons. One, it's really hard to block this unit with a bed or a couch or with furniture. So when it's mounted high up on the wall, there's going to be nothing that's going to be really impacting the airflow of the system. And it is like every opportunity to be running at its most efficient mode. The other reasons why wall hungs are so popular, if it's connected to a single zone outdoor unit, it's typically the most efficient. My personal favorite, and this is what's in my house on my foyer, is a floor-mounted unit. And why I like the floor-mounted units is, once again, architecture is real, and having the plastic line set covers connecting high up on the wall to the outdoor unit may not work for some people. With the floor-mounted unit, if it's on the first floor, all of the line sets can drop down into the basement and then straight out the outside of the home, kind of keeping the architectural integrity of the home intact. The other reason why I like floor mounts is I'm hoping that I'm not going to have any health consequences or challenges in the next like 15 years while the system's in use. But at some point, it could be really risky or nervous getting up on a chair or a step ladder with maintaining the filter of a wall-hung unit. So I do just like the idea that the filter is just down, it's low, it's easy to get at, and I think that should be acknowledged. And then they have ceiling cassettes as well, which we rarely see going in, particularly because most manufacturers, they're 22 by 22. And in most New England homes, every 16 inches, there's a piece of lumber. So to install a ceiling cassette is oftentimes a carpentry project. And I don't know, like maybe in the Pioneer Valley, it's a little bit more lax, but in say Eastern Massachusetts, that may require a structural engineer to be signing off before someone starts cutting away your ceiling joists. So ceiling cassettes, they are real, but it's much more of an application for a new construction or a gut renovation. Now, this is the most complicated category in my opinion. There's different types of ducted heat pump systems. So let's just go over a few reasons why you may want a ducted heat pump system. So I said architecture is real, so is an interior design, and sometimes having a big white clunky box hanging off of your wall is not going to make you feel great stepping into the room. So what's nice about ducted systems, it's going to be the same type of registers that you would see on a central furnace or a central AC. So there's going to be nothing that's going to be affecting the look and feel of your house inside. The other thing to know with ducted heat pump systems as well is, let's just say that you have a small bedroom. It's 10 by 10. The load of that room on the coldest day of the year is 2,000 BTUs per hour. The smallest ductless mini split is 6,000 BTUs per hour. It'll have 3 times the capacity that that home would ever need. It's not going to run efficiently if it's ductless in a small bedroom. So instead of putting in a ductless unit that's never going to perform well, you could put in a 6,000, a 9,000, or 12,000 BTU small ducted heat pump and split that heat pump's load over the course of multiple rooms. So that's this category, a compact or centrally, a compact, slim duct, low static, medium static. I'm sure if we asked the different installers out there, they would both give this product category a slightly different name. Then there's this, which is a centrally ducted heat pump, and the capacity of this type of equipment is going to be 24, 36, 42, 48, 60,000 BTUs per hour. It's designed to have enough heating capacity for an entire house or an entire floor. This type of heat pump, this is kind of all electric. With the centrally ducted heat pumps, they make this type of heat pump system to also sit on top of an oil-fired furnace or a propane-fired furnace. So sometimes with these centrally ducted heat pump systems, they're designed for a dual fuel application. And figuring out which of the two makes the most sense, it really is kind of what your goals are for the project. So if you're trying to decarbonize and electrify and never buy any more home heating oil, this could be the best bet. If you are finding an importance of like resiliency and redundancy and being able to kind of always choose the cheapest thing to run, because home heating oil could fall to $2 a gallon next winter. In my chart that I showed you earlier, that narrative wouldn't be true. Then say a centrally ducted heat pump could be making the most sense economic-wise. So some bullet points of like also choosing between a ducted heat pump and a ductless heat pump versus a ducted heat pump, and what's the right option may have a lot to do with what your existing distribution system is in your home. So say if you have an existing furnace, it is likely, if the ductwork is not 100 years old, that you could be ripping out that central furnace and putting in a central heat pump. And as long as your home has been well insulated and air sealed and there's no catastrophic air leaks happening, it's likely that a centrally ducted heat pump will be all that you will need. Say if you have an existing boiler and you don't have any ductwork to be distributing air throughout the home. So a boiler would be if you're heating with baseboards or column radiators. The best option may be putting in a couple ductless mini splits, like we saw out in the front. Alternatively, for some people, it may make sense to say, you know, this existing heating distribution system has served the home well for the last 100 years. Maybe it is time to make an investment in the home and put in ductwork as well, and now you're back up to the central ducted category. And usually when someone has an existing central air conditioner, usually that ductwork is most often pretty compatible, easily compatible with a centrally ducted heat pump system. There is a question when you do have central AC. They may have installed that up in the attic, and they're cooling the second floor, and they're letting all that cool, dense air naturally fall to the first floor. If that's the system, it's not going to be a great heating system. So sometimes when you do have an existing central AC up in the attic, sometimes the ductwork does need to get modified in a way that it can be a great heating system for the first floor. So we're going to do like a Goldilocks scenarios of like what's good, what's not so good, what's perfect. And I was asking Tom earlier today to get a percentage of people who are like heating with wood stoves or pellet stoves. But this is kind of my wood stove or pellet stove analogy. So if you heated your home with a wood stove or a pellet stove, do know that you could be doing the same thing with a ductless mini split. with getting the same level of comfort that you were getting out of those appliances, but you're no longer needing to go and, clean it out and refill it if things are of that nature. But for a lot of homes in Massachusetts, that's it. Grew up with some of the benefits of the central heating system, maybe this is less than ideal because this space over here is going to be comfortable, and as you move further away into, say, the bedroom wing of the home, it's going to be less comfortable. And say you already like to sleep in colder temperatures, perfect system design. Say you have a home office of one of those bedrooms, it will probably be uncomfortable there while you're sitting in a chair for 8 hours a day. So I'm not going to say that this is, let's say, undersized or this system's wrong, but this system design is likely going to be great for some people and less than ideal for others. When I'm thinking of this system, and I didn't ask any of the installers out there their rough pricing, typically I'm thinking that this is going to be $5,000 to $6,000 to put in a single zone ductless mini split. And the last thing that I'll touch on too as well with this, and this is a little bit of like a 201 level concept, but normally when you're controlling the equipment, you're just using a handheld remote and you're saying 70 degrees and you're blasting an IR signal over to here, and then it's measuring the return air temperature, and then it's dumping out what it thinks should be air hot enough to get this space over to 70 degrees. There's nothing about this equipment that's actually measuring the temperature in the living room or the bedroom or the bathroom over there. It's just taking a guess based off of like a software algorithm of like speed up the refrigerant or slow down the refrigerant or speed up the fan speed or slow it down. So I would say if anyone's interested in pursuing this type of a system, to always be pursuing, say, a wireless remote or a wired remote that you can put downstream from the system and actually get that space exactly where you want it to be set at. The next thing that we have is what's called an oversized system, and this is what a lot of installers typically pivot to. And I think that there's a few reasons why they kind of end up designing with oversized systems. So I'm going to just say hypothetically, this is a small condo. The heat load of it is 18,000 BTUs per hour. The smallest multi-zone that supports 4 indoor units is a 36,000 BTU per hour system. When you go and you say, I want 4 ductless units, and that's how you start off with the design, it's very easy to be blowing past the load of the home. And as we looked at earlier with the coefficient of performance, where I said like it should be around 2.8 or close to 300% efficient, when you oversize the system by 50% or 100%, that's one of the design factors that could cause the coefficient of performance to fall at like 200% efficient or having a COP of 2 over the course of the year. So the other thing about this, it's like this system happens because there was a baseboard here or a column radiator there and a column radiator there and a column radiator there, and no one wanted to have a cold room. And an installer didn't want to charge someone $15,000 and give them a cold room. So instead they put in an extra system, they blew past the sizing, but then they ended up dinging the overall performance. So oversized systems is something to be on the lookout for. I would never talk to anyone and just say like put a mini split wherever you have a register or a radiator, but this is kind of what sometimes naturally happens. The other thing to note about this, and why I think that this is bad, is because insulation is a real building material and it really works. So if this space is 70 degrees, and this space is 70 degrees, and this space is 70 degrees, why is that space not 70 degrees independent of the heating system being in there or not? So it's like, all right, maybe this is not 70 degrees without a heating system because there's 1, 2, 3 bad single pane windows with leaky storms. So there's usually ways to be buttoning up the thermal envelope of the home to kind of eliminate putting in a ductless mini split unit in each and every room. And as a personal anecdote with my own home, I have 2 children. I love them dearly, but neither of them have ductless mini splits in their room, and they are perfectly fine. Even closing the door all night on a cold winter day, you wake up and it's 64 degrees in the room. It's not abusive at all. So do know that like you really don't need to be putting in a ductless mini split everywhere. Just because there's an existing register or radiator. And the other thing to know, just because you guys do have a slightly older housing stock over here, when your home was built and there was no insulation in the walls, the windows were single pane without triple track storms. Air sealing had not yet been invented. Yeah, every single room needed a radiator, needed a register, but just say if you button up our homes over time, they get tighter and tighter and tighter. So this is what we like to see, a properly sized heat pump system. The load of this home is still 18,000 BTUs per hour. Now we have a 9,000 BTU ductless mini split. We have a 9,000 BTU per hour ducted heat pump. We're dropping registers in the 2 bedrooms in the back. There'd be a separate thermostat on this wing of the home, a separate thermostat on this wing of the home. It's likely going to be a cheaper install than just putting in a ductless mini split in each and every room. And this is the type of a heat pump system that is much higher likelihood to be, say, 300% efficient over the course of the year than really any of the other types that we had looked at earlier. The other thing too, we've been talking about these things as heating systems, but if I go back a slide, this is a little bit of an important concept. Say that the heat load of the home is 18,000 BTUs, the cooling load is going to be like 9,000 BTUs. And just to make sure that this makes sense for everyone, when I'm thinking of heating a home in Massachusetts, I'm thinking of going from 5 degrees all the way up to 70 degrees, like a 65-degree temperature difference. And when I'm thinking of cooling a home, I'm thinking of going from 90 degrees down to 75 degrees, a 15,000 BTU, a 15-degree temperature difference. So it's always going to be much easier to cool a home in Massachusetts than heat it. So the cooling load of this home is probably 9,000 BTUs per hour, and we put in a 36,000 BTU system. So at that point, it's 4x oversized. Versus say when we do have this option, where we could just be putting on one piece of equipment, running at 9,000 BTUs, we're matching the cooling load perfectly, and this is going to give you the best humidity control possible. All right, so now we'll talk about cost, rebates, and tax credits, and there'll be some nuance over here and a little bit of wait and see, but I'm happy to just talk about everything that's available today. So how much do heat pumps cost? When I'm thinking of a ductless piece of equipment, I'm thinking $5,000. So if you just want to put in one ductless mini split, $5,000. When I'm thinking of a ducted heat pump system, I'm thinking probably $15,000 to $20,000. And say if there's no ductwork existing, and you're putting in a brand new centrally ducted heat pump system, I'm thinking probably $20,000 to $25,000. A lot of times, as you get further away from Boston, the pricing becomes more favorable. So it is a potential that the numbers that you may be seeing in your quotes may be a little bit less than that. One thing to be aware of is this is a large electrical appliance, and it does take up real space on the panel. So not only is, say, a heat pump system going to be taking up the spot of 2 circuit breakers, but if you only have 100 amp service coming into the home, a whole home heat pump system may be taking up 30 or 40 of those amps. And say that you want to put in an induction cooktop. There's another 40 amps, and now you want to be putting in a level 2 EV charger. That's 20 to 40 amps. So you could be totally taking up all of the capacity of your electrical service if you only have 100 amp service coming in with just some of those measures that people are telling you you need to do to be decarbonizing and electrifying your home. So it's something to be thinking about, and you know that typically with most regular sized homes, if there's already 200 amp service coming into the home, pretty much everyone can adopt air source heat pumps without needing to be thinking that you're likely needing to be upgrading your electrical service. But if you have a 100 amp service or a 60 amp service, it will probably be likely that you will be needing to be upgrading that in the near future. And the other thing that I'll always just touch on over here is like, worst comes to worst, if you are cutting it close, it is just a circuit. You are going to be tripping the breaker, but nothing explodes, nothing catches on fire. But it is safe, like you don't want to ever be thinking in the middle of February going down into your freezing cold basement to be flipping the breaker. So let's get into the rebates. Oh, and I guess for the electrical service, if I were thinking about the cost of upgrading it, it's about $5,000 is typically what I see in more eastern Massachusetts. So the first incentive we're going to talk about is what I would have been eligible for. This was around when I decarbonized my HVAC system. It's called a whole home heat pump rebate. And if you go and you put in a heat pump system that meets between 90 and 120% of the building's heat load, you can be claiming a $10,000 rebate from MassSave. To claim this rebate, you do not need to be ripping out your existing furnace or ripping out your existing boiler. You just sign an attestation form saying that I am only ever going to use this system in case of emergencies. So it's pretty flexible. They were pretty lenient on it. And with most installers, they are somewhat flexible in figuring out what a whole home distribution system looks like. So if you are, say, a rugged New Englander and you're like, yeah, I just want to put one ductless mini split on the first floor, one ductless mini split on the second floor, and the overall comfort of my home would be the same as having a wood stove or a pellet stove per floor, that's a $10,000 rebate for $10,000 or $12,000 worth of equipment cost. So sometimes this could be extremely impactful with just the upfront cost. The next thing that we have is the partial home system. So say that you have, you want to do heat pumps, but you want to maintain your 4-year-old propane-fired high-efficiency furnace. You could go and put on a heat pump system directly on top of that furnace, and you could be claiming a rebate of $1,250 per ton. And the per ton, I just have this over here, what it is, it's a legacy metric that's commonly used in the HVAC industry of how much, what a ton of ice would actually be doing. And a ton of ice would be removing 12,000 BTUs per hour, so that's where the tonnage on heat pumps go from. But do know that with MassSave, they measure the rebates per ton. And say if you did put in, your installer put in a 2.5 ton system, they do acknowledge partial tonnage too. So they don't always round it down or round it up. They would then pay a rebate of 2.5 times $1,250. And this may be, maybe I'll slightly get in a little bit of trouble for this because we're never supposed to talk about rules of thumb with designing HVAC systems. But for most homes, if you just take your square footage and you multiply it by 25, that's how many BTUs per hour the home is roughly going to need. And knowing that on a high performance home, you take your square footage and multiply by 15, or say you have a leaky farmhouse, if you multiplying by 35. But say once you do that exercise and you divide it by 12,000 BTUs per hour, that will probably get you in the ballpark of thinking of what a partial home rebate would look like. So square footage, multiply by 25, divide by 12,000, that will probably be what you should be thinking about for a partial home rebate. The other thing that I'll just touch on over here, there's also $10,000 for a whole home air-to-water heat pump system, and we'll learn about those in just a second. And if you were interested in geothermal, it's a $15,000 rebate. Last thing, I just added this note on here as well. Do you know that with Mass Save, I'm sure there's some do-it-yourselfers out here, you do need to work with a authorized contractor to be installing the heat pump system to be getting the rebates. So Mass Save, do you know if you may, Mass Save, everyone who is a regular ratepayer who's paid into the program is eligible for all of the rebates that we just highlighted. If you're, say, on fixed or low income, then your heat pump program would likely be done in conjunction with the local community action program. But Mass Save does want to, they did roll out a few years back a moderate income program, and depending on your household size and your earned income, then it could be a mechanism to cause the rebate to get a lot more attractive. So say if you're a family of 4 and you make between $81,000 and $108,000 per year, instead of the partial home, $1,250 for a partial home, or $10,000 for a whole home, it does jump up to a flat $16,000 for a whole home heat pump system. And for partial homes, it no longer becomes defined by tonnage. It's just going to be a flat $8,000 rebate. So if your household income falls within these ranges, just putting in a ductless or, a ductless mini split system, or say 2 ductless mini splits, this rebate is really going to be covering, if not all of it, probably about 80 or 90% of the project. And once we're thinking about the federal tax credits, then it'd probably be about 100% of the project. So, do you know that anyone, getting Social Security benefits, and these, households with a stay-at-home parent, it's pretty easy to fall within that income bracket and take full advantage of the moderate income program. And I won't be talking too much about Mass Save's other measures, but say if you do fall within that bracket, then Mass Save insulates your entire house for free as well. So it does become a super good cash windfall. As far as affordability, let's just say with the heat pump system, full home heat pump system, you want to put in brand new ductwork, you want to put in two ductless mini splits, it could be a $30,000 project. Let's just think about what that would normally mean in relation to having a Mass Save heat loan as well. So Mass Save would see that there's a $30,000 heat pump project. They do a $10,000 rebate, so now you're stuck with, say, $20,000 kind of out of pocket for year 1. They allow you to finance that $20,000, 0% interest over the course of 7 years using the heat loan. So it does take that $20,000 and it makes it, monthly payments of, a couple $100. And some things that I really like about that heat loan is you can use it for other measures as well. So you could be using it to be putting in a high efficiency on-demand hot water system if you wanted to have propane for your hot water. You can use it for upgrading your main electrical panel and the electrical service coming into your home. You can be using it to change up single pane windows and single pane windows with storms to triple panes, and you can also be using it to finance any additional insulation measures. And something really cool that they added 2 years ago, if you are interested in, say, a Tesla Powerwall or a Generac on-home storage solution, you can also use it for residential battery storage as well, which is really good. But the thing that I like most about the heat loan, well, I guess I like 0% financing over 7 years the most. What I like second most about the heat loan is Once you submit your project over to it, it would happen before any rebate processing. But it gets eyes on the project for a mass save, and then mass save takes a look at the project and they say, yes, this equipment's eligible for the rebates. So when you do get the equipment installed, you know that what your installer put in is eligible. Because I've worked on projects where they haven't done that, and then the installer put in a piece of equipment that wasn't eligible, and then you're fighting with mass save over $10,000, which is a real lot of money. So I do just like that it gets eyes on the project for mass save. And just a high-level concept too is your money can always be doing something better for you over the next 7 years than buying HVAC equipment today. So it really does make a lot of sense if you are thinking about heat pumps to always take advantage of the heat loan. So say that you put in a heat pump system where you put it one on the first floor and you're going to run that thing the same way you would a pellet stove or a wood stove. You could, let's say, just go and you wake up in the morning and turn it on, and then you could go to bed at night and turn it off, and then you could go look at the weather the next morning and be like, oh, it's really cold this morning, I'm going to keep the system off and I'm going to just run my central heating system instead. Instead of worrying about all of that mass save when you are doing a partial home solution, they're always going to make the installer come up with some integrated control strategy to make those decisions happen somewhat flawlessly and ensure that the equipment is always able to run at its best efficiency. So some examples of this would be, let's say you have a propane or an oil-fired furnace and you put a central heat pump sitting right on top of it. You can have that connected to a Honeywell thermostat, a Nest thermostat, an Ecobee thermostat, Emerson thermostat. They all make these. And what happens is, if it's Wi-Fi enabled, it's just going to be pulling weather data from the internet. And anytime it's below 30 degrees outside, that thermostat will say heat pump turn off, fossil fuel-based system turn on. And MassSafe likes that because it can kind of guarantee some of the savings that they're projecting to the state. Let's say that you put in a ductless mini split or 2 ductless mini splits, and you still have the central heating system in place. These things, which look like putts, what they'll do is they'll blast an infrared signal over to the mini split and say turn off or turn on, and then those pieces of equipment will communicate with the thermostat and have that happen automatically, that switch over. So if you are doing a partial home solution, do know that integrated controls are required. And a lot of times, if you are just working with if you are working with Mitsubishi equipment or Fujitsu equipment like they sell out there, or Samsung equipment, there is oftentimes some pretty elegant apps as well that you can have on your phone that kind of make this a little less daunting feeling. All right. So let's just go and look at what integrated controls mean to heat pump equipment and performance. So I have a house over here, and then I have this axis over here. And then on this axis is 70 degrees all the way down to 0 degrees. And what I would see is as the temperature drops, the heating load of the home goes up. So where this house finished off right at 0 degrees is probably right around 45,000 BTUs per hour. Your design temperature, I think, is 2 degrees. So what a design temperature means is that 99% of all winter heating hours are at or above 2 degrees. So you're not supposed to design a heating system for the record low temperature, because what that means is that may only occur 0.0001% of all hours experienced. So at 2 degrees, we need probably right around 45,000 BTUs per hour. I have proposed, or I have received quotes for 3 different types of heat pump systems. So the first is a 4-ton heat pump. So this is going to be a standard heat pump system. And what I would see is it starts off with actually 48,000 BTUs per hour, but as the temperature goes down, it loses its heating capacity. And then kind of over here, it starts to kind of exacerbate. So if I put in this 4-ton standard heat pump system, I would need to have integrated controls installed, and what I would have it set to is probably right at 20 degrees, heat pump system turns off, fossil fuel-based system turns on. Alternatively, I could have just put in a 4-ton multi-split, mini-split system. And over here, this is a cold climate system, and it doesn't have a capacity drop. This, if I continue it onward, I would see that this mini-split heat pump system is always going to have enough heating horsepower, heating capacity for my home. If we were worried about polar vortexes or sub-zero temperatures, what I can tell you is nothing catastrophic happens. Your house is just not going to be 70 degrees. So when it's -3 degrees outside, maybe the best that you'll do is 68 degrees. And if it's -10 degrees outside, maybe the best that you would be doing is 60 degrees. There's a lot of additional ways to add heat into a home that's not a central heating system. So an electric space heater, putting a pot of water on the stove and adding some humidity in the space, putting on some nice moccasin slippers, putting on an electric blanket. Like, there's other ways to solve this question that doesn't just mean buying more mechanical equipment. I could have also received a proposal for a 2-ton mini split, so just say 1 ductless unit downstairs. And if I'm looking at the performance, I would see that that 1 heat pump system would likely not have enough heating horsepower or capacity right at 32 degrees. So there's never anything with like right or wrong. It's really just figuring out what the home needs, figuring out what the equipment can do, and just making sure that the homeowner or you would be aware of what strategy would need to take place. MassSave does have some prescriptive cutover points too. So if you are claiming the partial home rebate and you do have home heating oil, they do want to see that switchover happen at least 30 degrees, and with propane at least 15 degrees. And my personal feeling with propane, if you're designing a heat pump system to switch over at 15 degrees, you might as well just be pursuing the whole home heat pump rebate at that point, especially with what propane prices are in Massachusetts. So, incentives for partial home systems, $1,250 for most homes in Massachusetts. It really does mean between just shy of $4,000 to $6,200 rebate. Do you know that integrated controls are required in kind of partial home solutions is being proposed? And do you know that integrated controls in 2023 can be rather elegant with all the different solutions? So on the federal incentives, last year the Inflation Reduction Act passed, and what it means is that every single year you could be tapping into a $2,000 tax credit as well for adopting heat pumps. So what that could mean is this year I'm putting in a ductless mini split. It costs $6,000. I'm getting a 30% federal tax credit up to $2,000. I'm maxing out the tax incentive this year. Next year, you do the same thing. The following year after that, you do the same thing. And now you've got whole home heat pump systems. So do know with the tax credit, as long as you have the tax liability, this could definitely be acknowledged to kind of lower your kind of upfront cost or decarbonize over time. There's some small money for electrical upgrades. The same tax credit's also going to be from like for heat pump hot water heaters. But the big thing is you are thinking about this, you can claim it every single year. There's going to be federally funded rebates coming to the states. And I'm sorry to report that the website that I was using to track all of this, they just switched it from saying spring of 2023 to late 2023. So it's likely there's going to be a little bit more of a question mark of how this is actually going to look once it rolls out. Part of the problem is they need to figure out how to get these rebates applied to all 50 states. And even in Massachusetts, it's like, oh, that's a Mass Save problem. Like, let's just give the money to Mass Save and they can figure out how to equitably, I can't say that word, transfer the money out to the, disperse the money out equally to people in the states who would be eligible. But the problem even with that is like there's a handful of towns that have municipal light plants in Massachusetts. So there is a lot of complexity with getting this figured out, but really what it's likely going to be meaning is if you are going to qualify under this moderate income program, that there's going to be anywhere between $8,000 all the way up to $16,000 for heat pump systems. And the website that I keep tabs on this is the Rewire America IRA calculator, and it's really good because you can see what all of the other applicable measures in that bill could mean to your home. Sorry. And I said 8 to 16, but I meant to say 4 to 8. But these are really what the levels are going to be when you do qualify into the, if you do qualify under the kind of like moderate income level of that program. Yeah, and these are, here's just kind of a summary of some of the other measures. So if you do fit within the income range, $8,000 for heat pumps, $4,000 for electrical panels, bringing in better electrical service into the home, or resolving knob and tube, heat pump water heater. So it really is like a pretty comprehensive list. So we're going to just talk about some of the other things to be keeping in mind regarding heat pumps. So most of what we've talked about has been an air-to-air based system. Do know that there's heat pump hot water heaters as well. Typically this equipment, where it really is just like the same as a window air conditioner, where like everything is packaged together. We have a heat pump system sitting on top of a hot water tank. And what happens is it takes heat from the basement air and it steals that energy and it transfers that energy into your domestic hot water heater. And the great thing about that, and I'll talk about the bad thing about that in a second. The great thing about it is going to be that all 4 seasons, this contraption is going to be using, say, 2 to 3 less electricity or energy than what you've been using in the past. The other thing that's great about this is one of the byproducts is stealing heat off of the basement air, is also stealing moisture off of the basement air. So this kind of doubles as a dehumidifier. The bad thing about this is 1/4 of the year, stealing heat out of the basement could feel very risky in terms of like pipes freezing or the basement becoming colder than you'd ever want it to be. And that's why instead of these being called heat pump hot water heaters, most manufacturers refer to them as hybrid hot water heaters. And there's buttons on the device where you can do this right from your phone, but you can switch it from running as a heat pump to having it run just as an electric storage tank. So say on a day like today, we're in the middle of January, stealing a little bit of heat out of the basement, not problematic. Next week, stealing a little heat out of the basement could be problematic. So heat pump hot water heaters, they are real 10-year warranty from pretty much all the manufacturers. And if you have a local plumber, I just passed the Home Depot on my way over there, you can print out on the Mass Save website a $750 instant rebate that the plumber can bring into Home Depot, or you can bring into the Home Depot and pretty much get this equipment for half off. So typically a 40-gallon tank costs about $1,500, $750 rebate. And for the plumber, it really is just the same plumbing connections that they've always done before. The challenge over here is potentially if you are switching from using a indirect hot water heater or superstore off of your boiler, is you are going to be needing to run a new circuit over to it with a 30-amp breaker. So oftentimes heat pump hot water heaters for the first one that you put in is more of an electrical project than a plumbing project in terms of expense. The next type of heat pump system that I just want to highlight is geothermal systems are real. And the benefits of a geothermal system is the ground temperature in our region is pretty stable, around 45 degrees, and it's a lot easier to generate steal heat from 45-degree ground temperature than 0-degree air. So a geothermal system doesn't need to work nearly as hard in the wintertime as an air source heat pump system does. Geothermal systems, though, sometimes you're needing to buy 3 components. So you're needing to do all the earthwork or the site work. You're still needing to buy a heat pump system, but then also sometimes you're needing to buy a brand new distribution system as well. So it's not uncommon to see, say, geothermal heat pump projects coming in closer to $70,000 or $100,000 than an air source heat pump system. But with the geothermal system, there will be a 30% federal tax credit, which helps out a lot. So it's pretty obvious when you're just looking and you're thinking about temperatures, like you have the house at 70 degrees, the ground temperature is 50 degrees outside versus 50 degrees underground versus 15 degrees outside. That heat pump's going to work a lot easier in the winter time. And especially in the summertime, over here, this heat pump system can just take the heat from your home and it's already cooler underground. So you pretty much don't even need any refrigerant process to happen to be phase changing materials and things like that. It's just cooler underground. Let's just continually dumping the heat from our home down there. So ground source heat pump system, 30% federal tax credit. This program, alternative energy certificates, is a little bit broken right now, but there's money that's coming from the DOER for that, and they're working on fixing it. $15,000 for mass save. You can finance it over the course of 7 years using the heat loan. And with all these HVAC projects, there's no sales tax on any of the any heat pump projects. The last one that we'll talk about is air-to-water heat pumps. So this, you may be thinking if you have baseboards or you have radiators that this is probably what you should be thinking about, but there is some complexities with it. So there's lots of people that believe that hydronics is the most comfortable way to be heating a home. Some people think that forced hot air or air blowing around is not as comfortable. So over here, you could be using baseboards or radiant floors. It's very easy to zone water, get water flowing to where you want, and it's a little trickier to get air going where you want. Quiet, it could be used to heat up your domestic hot water. You can use the system for chilled water as well. Now we're into the tricky part, and this is the trickiest part. The water of these systems that it can put out is around 140 degrees. Most people's baseboard systems are designed for 180 degrees. Just because it can put out up to 140 degree water, it's much happier generating water at 90 degrees or 120 degrees. So sometimes to be able to adopt an air-to-water heat pump, it means a couple things. One, really reducing the load of your home, or two, possibly changing out some of your radiators to a low temperature hydronic distribution system. So I think that this expectation, not compatible with typical baseboards and radiators, that while it's partially true, you've got to first do the math with your plumber and figure out what each of the rooms need, how much radiation can a baseboard put out when you have 120 degree water, 140 degree water flowing through it, and then you can find out whether or not it's compatible or not. So I just want to highlight what this system looks like in practice. You have a heat pump system outside. It is storing all of that energy in something that looks very similar to a hot water cylinder. And it's just going to be keeping the water in here at 120 or 140 degrees. And from this device over here, then it would be going to various manifolds where it would be distributed to radiant floors, European-style wall-hung radiators with thermostatic radiator valves to improve the comfort. Or this last part of thing over here, this could be a ducted air handler as well. So you could be going from the heat pump to the thermal storage to a ducted air handler down in your basement and a separate one on the attic. And then in the great room, you could be having a European-style radiator. And then in the bathrooms and the kitchen on the first floor where you have tile, you could have radiant floors, all from this one heat pump system. So tons more flexibility in design with an air-to-water heat pump system. And I am pretty excited over the course of the next couple of years seeing more installers get comfortable with that. As far as just a little bit of Abode and what we do. So I always say first start off with a massive energy audit and make sure that you're as buttoned up as possible. And a lot of the energy auditors are becoming more savvy about heat pump equipment, and hopefully they can get you pretty far along on getting your heat pump journey started. Say at the same time, it may also make sense to start receiving quotes and just see whether or not through your friends, neighbors, energy committee, maybe they can help you make Apple, heads and tails out of the different equipment. But say that you are stuck, that you're thinking that this is a big project, a complicated project, and you just want to talk. Do you know that the company that I work for, we do retail consulting as well, all virtually over Zoom. It's $150, it's an hour, and then it's additional email support to get you further along. That I think it's cool, it's helpful. I think what my company is doing that's really exciting is we have this, which is called the quote comparison report. And what we do is we go and we read through every single proposal, we figure out what's going on in your home, and then we plot the performance of your home over the performance curve of heat pump equipment, and then we're able to tell you which is going to be the best cooling systems in terms of efficiency, what's going to have the highest coefficient of performance, whether or not the systems are sized, oversized, or undersized, the impact in terms of dollar cost as well as carbon. So what we're able to do is really kind of give you a good look of whether or not it makes more sense to be putting in 3 ducted systems or 1 ducted systems plus 5 different mini splits. So you are able to really get an apples to apples comparison of all of the different ones. And just as a high level thought, it's my belief and Abode's belief that this is something that SAFE should be doing, but right now there is just a little bit of a hole in the marketplace of you versus energy auditor versus 3 different HVAC contractors and just but yeah, just decarbonization services or electrification services should be something that someone doesn't have to pay out of pocket for, but that's where we are right now. And if I am just justifying it, it's $150, and I totally know that $150 is real money, but it's that's what, 30 gallons of home heating oil right now. And it really could be the difference of the selecting equipment that they say is the best versus actually being able to select the right type of equipment, which will be saving thousands of dollars at the end. So I just want to highlight that we are potentially here to help, but it's not free. But I'm going to be around for the rest of the event. So if you do want to kind of get started with just talking about your own project, I look forward to speaking with you. And thank you again for having me and putting on this great event. Thank you.